For this part, we will introduce OSPF advanced features. For the OSPF advanced features, the second part is default route. So now let's see this part. And this page introduces the background for default routes imported by OSPF. So here actually lists some problems happens in our network. And the first problem is a manually configure static routes and default routes. So as we know in common in the network, if we want to configure the static routes or the default routes, we will use the commands like IP routes, right? And at the 0.0.0.0, okay. And then at the next hop. So for this command, we can configure the static routes or the default routes. So if the engineer configure every routing entry, so it will waste much time. This is the problem, right? And then if there's so much routing entry, we will add to the route table. So for our device, we will occupy the memory to store all the routing entry information to our routing table. So this is the second problem. And the third, our network sometimes will have the trouble. So for our engineer, we have to do the troubleshooting to debug the network and find the errors in our network and recover the network services. So if we configure every static routes or default routes manually, so we have to check many configuration on our device. Of course, we need to waste much time on troubleshooting. So it's not a good way for us to configure static default routes manually one by one. Okay. And then with the increase of the network scale, so we know it's very important for the engineer to configure and manage our device in our network to relate the covalence and redundancy. So if we configure every static router or the default router manually, this way we'll lower the redundancy and the covalence. Okay, next is the router distribution. And we know the router distribution actually help us to communicate the connect between different AS, like the AS1 and the AS2, right? And we set the AS1 is the OSPF process 1 and set the AS2 to OSPF 2 process. So actually the two different process. If we want to the two AS communicate with each other, we have to do the route redistribution on ASBR device, right? So this is the route distribution. So for another scenarios, maybe the route AS2, we enable other protocol like the EZS, like the RIP, or other protocol. So if we want to the AS1 and communicate with AS2, we also have to do the router redistribution on ASBR device. But here, the router distribution method cannot import the local static default routes. So this is a problem. We can't use the router distribution on our OSPF device. Okay. And another reason is the default routes learn from other protocol to OSPF. So for these two reasons, we can't do the route distribution and to relate the static default routes on local device or from other protocols. Okay. And next is OSPF can import default routes through comments which differ by scenarios. So for here, we will know in the OSPF we have many scenarios. We will use different commands like the default information originate, like the default information originates always, or no summary. These many commands will use by different scenarios. Okay, so for the next page, and for the first scenario is a default information originate. For this command, here if we want to use this command, we have to follow the rules. Okay, we have to follow the rules. So what's the rules? The rules is the routing table of the device must contain the default root 0.0.0.0. Okay, so it means in our routing entries, we have to see this routing entry. So in our device, we can use the show IP router command to see if our routing entry has the default root information, right? And for this command, otherwise the OSPF cannot successfully deliver the default root. Okay, to see this topology, we can see this is a RGW device. So sometimes we want to do the default information originate, and we configure this command default information originate on RGW device. So now if we show IP router this command and we say one routing entry is the 0.0.0.0, okay, and we can say this routing entry, it means we can use the default information originate this command to do the default route. But now, if we use this command and we can't see this routing entry, so we can't deliver the default router successfully. So this is the sentence means. Okay, and for our RGW device, actually we can learn the static routing entries from two ways. First is the static routing entry, like we use the command IP router to create the static routing entry. And another way, we can learn from another dynamic routing protocol. So for the dynamic routing protocol, we also can see the default routing entry by show IP router. After this, and we can configure the default information originate on the device, and then the device will deliver the default router information to R1, to R2, to R3. Okay, so this is the first scenario for us to do the deliver default route. And for the default route, actually, is the type 5 RSA. So we can see the type 5 RSA on R1, R2, R3. We can use the show IP router OSPF and to see the routing entry is OE1 and OE2 because the type 5 is external RSA information, right? And of course, we can use the show IP OSPF database to see. Actually, in the database, we can see the type 5 RSA information on R1, R2, R3. We can find this RSA information. So this is the first scenario. Okay, next. Here is the scenario 2, and for the scenario 2, the command is the default information originate always. So for this command, we can say there is differences between last command, and we add the always parameters follow the command, right? And this is means whatever in our routing tables, we don't have the default route or we have the default route, we will deliver the OSPF default route to other routers. Okay, So here we can say for the RTW device, and we use the default information originate always this command, and then the RTW device will deliver the OSPF default route to R1, R2, R3. Okay, and then we can use the show IP route and to see on R1, R2, R3 device, we can see the default routing entries. But for this command, actually sometimes will cause the problem for our network. And for R1, R2, R3, actually we can see the default route, but if the R1, R2, R3 want to access the external network, sometimes maybe the communication will fail. So why? Why? Because we use the default information originates always this command, and whatever the RTW have the default route or not have this default route, right? So it means maybe the RTW don't have this default route. And for the R1, R2, R3, want to communicate with the external internet, and we will send the packet to the next hop. So the next hop actually is the RGW device, right? Because of the routing entry. And we find the routing entry for the default route is the RGW. And the R2 also sends the packet to RGW. The R3 is the same, right? And after this, the packet to the RTW, and the RTW will check the routing entries, and we will find we don't have the routing entries for us to access the internet, right? And then the RTW will through the packets. So the R1, R2, R3 actually have the routing entries, but the RTW don't have the routing entries. So now in the OSPF area, the device have the routing entries but can't access the external network because the RTW don't have the routing entries. So this is a problem if we use the default information underneath always. So if we want the device can communicate with the external network, we have to create the static routing entry or to create the default route on RGW device so that all the devices in OSPF area can access to the external network. Okay, so this is the problem if you use this command in our network. Be careful. Okay, next. And this page actually introduced the scenario 3 for step area, and we know the step area is a special area for OSPF. And we have the step area, totally step area, and SSA area, and totally SSA. So for the step area, actually, if we configure an area to become the step area, the step area can deliver the default route automatically. It means we don't need to configure the default route manually. So this is a step area. So here we can see the topology, and the R2, R3 belongs to the area 0, and the R1, R2 belongs to the area 1, and the R3, R4 belongs to the area 2. And for this topology, actually, we set the area 1 to become the step area, and the command is the R1, and we ending to the OSPF process and do the network. Maybe we can set the route ID information, and then we use the command area 1 step. Okay, use this command, and then for R2 device, we also have to do the OSPF process and do the network and set the area 1 to become the step. So now this area has already become the step area. Okay. And for the step area, we can deliver the default route automatically to the step area. So now if we go to the R1 device and use the show IP router OSPF this command, we can see the type 3 RSA information. So the routes is the OIA, and we can see the OIA, the routing entry is the 0.0.0.0. Okay, we can see this routing entry on our routing table. So we don't need to do the additional configuration on our device. And for this two command, actually, the area 1 step no summary and configure on R2 device. The R2 device is the ABR device for the area 0 and area 1. If we configure this command on ABR device, it means we set this area to become the totally area. Okay, totally area. So this is the command's function. And after this, actually the R1 receives the default routing information from the R2. And for this routing entry, the default cost is 1. Okay, is a 1. If we want to change the cost of this default routing entry, we can use another comment. Is the area 1 default cost 20? It means we change the default routing entry from the 1 to 20. Okay, so this is comment's function. And for the next, and for this scenario, actually, is the ABR in the NSSA delivers the default truth. Actually, we know the NSSA area is a kind of special area, but for the NSSA area is the differences from the step area to the step area, because for the NSSA area, and we don't deliver the default route automatically, but for the step area to the step area, we can deliver the default route automatically. So for the NSSA area, we had to manual the default route. This is the differences between the NSSA area to the step area. Okay, so for this topology, we can see now we will set the area 2 to become the NSSA area. So we have to configure the NSSA command on R3 and R4. Okay, and for an SSA area, actually we can redistribute the external routes information into our network. Okay, this is another differences between the NSSA area and the step area. And on R3, we can see the configuration is the router OSPF1 and do the network and set the area to become the NSSA. So actually, we also have to do this command on R4 device. Okay, after this, actually, we will become the NSSA area. And for the NSSA area, now we can check the routing entries on R4 device. We can use the show IP route. And now, if we don't use the default information originates this command, and we can't see the default entry on R4 device. So now, if we use the default information originate, we can see the default routing information on R4 device, and then show IP router, we can see the ON1 or ON2. This routing entry on our routing table. Okay, so why the mark is the ON1 and ON2? Because actually for the NSSA area, we know if we enable this area to become the NSSA area, the area will generate a new type RSA information is a type 7 RSA, right? So for the RSA type 7 information, we will generate the ON1 and ON2 routing entries in our routing table. So now we also can use the shoe IP OSPF database and to see in our database we also can see the Type 7 RSA information. And for the Type 7 RSA information, actually it's special for an SSA area, but for other area we can't receive the Type 7 RSA information. Okay, and for the routine entry, we will exchange the Type 7 RSA information into the Type 5 RSA information on R3, and then other routers can see the routing entries by Type 5 RSA routing information. Okay, so now the last command, and we can say the command is area 2 on SSA default information originate. So for this part, actually it means we deliver the default route manually, and then we add the metric 1. It means we set this default route, the metric value is 1, and then the metric tab is the 2. It means if we see the routing entries in our routing table, we can see the tab is the 2. It means we will generate the ON2 routing entries in our routing table. Okay, so this is the command function for an SSA area. Okay, so for the next page, for the scenario 5, actually is the ASBR in the SSA delivers the default route. And we know right now we have learned the deliver default route on ABR, right? On R3 is the ABR device for the SSA area. But now if we want to deliver the default route on ASBR device, so here we can see the R4 connect with the OSPF process, and then actually we do the redistribution on R4. So the R4 is the ASBR device, right? And for the ASBR device, we want to deliver the default route. Also, the command is the same. First, we have to set the SSA area on R3 and R4. So we have to do the area 2 on SSA on R3 and R4. After this, we use this command is area 2 on SSA default information originate metric 1 and the metric tab 2. So it's the same command we use on ASBR. But the differences between two scenarios is if we use this command on R4 device, we have to make sure in the R4 device we have already contained the default route. It means now if we show IP route, we have to find in the routing table there is 1.1.0.0.0.0 this routing entry in our routing table. Okay, so for this routing table, and we have the default route information on R4 device, and then the R4 device can deliver the default route successfully. So this is the differences between ABR and ASBR to deliver the default route. Okay. And for the R4, actually the R4 is an SSA area device. So the R4 delivers the default route. Actually, will generate the Type 7 RSA routing information because for an SSA area, we will generate the Type 7 RSA information. So we also can see the ON1 or ON2 routing entries in our routing table. And now, if we use the command to set the metric tab become 2, so we can see in the routing table, we are marked as the ON2 because we adjust the metric tab to become the tab 2. Okay, tab 2. So we can see the default route entry in our routing table. So this is the scenario 5. And next scenario, and for this scenario, actually, also to introduce a special area is the totally SSA area. And the APR in the totally SSA automatically delivers the default route. This is the differences between the SSA area and the totally SSA area, right? And for the SSA area, we have to deliver the default route manually. And for totally SSA area, actually, the default routes can generate automatically. It's same with the step area and the totally step area. So here for the APR device in the totally unnecessary area, automatically deliver a default route of type 3 RSA information to the SSA. So here we can see for this topology, and we set the area information. And for this topology, the R3, R4 belongs to the unnecessary area. So we have to configure the commands on R3 and R4 device. So set the area 2 to become the unnecessary, and it means the area 2 unnecessary is command will configured on R3. And then also we have to set the area 2 unnecessary command on R4 device. But now if we want to set this area to become the totally unnecessary area, so we have to add the no summary this command on R3, because R3 is the API device belongs to the area 0 and belongs to the SSA area. We just can use the command on R3. We don't need to configure the area 2 and SSA, no summary on R4. We don't need to add this no summary on R4 device. Okay, so now we become the area 2 as the unnecessary, totally unnecessary area. And for totally unnecessary area, actually, the APR can generate the default route automatically. And for this router is from the NSSA area, and we can see it's a type 3 RSA information. So it will generate the default routing entry, and we can use the show IP route to see this entry. Okay, so this is the totally unnecessary area for delivering the default route. So here we can do a simple summary and the different scenarios we use in OSPF, right? And especially for the different special area, the step area, totally step area, and the unnecessary area, totally unnecessary area. Actually, for the step area and totally step area, totally unnecessary area, and we can deliver the default route automatically, so we don't need to do the additional configuration. But except this, we also have the another special area. It's the unnecessary area. For unnecessary area, actually we have to deliver the default route manually, because the unnecessary area can't generate the default route automatically. And also, we can use the command to modify the metric tab, the metric venue for the default route. So this is the special area for default route. Of course, we also have another two ways to configure the default route. First is the default information originate, and second is the default the route information originates always. So for the always, actually, whatever on the device we have or we don't have the default route, we also can deliver the default route to other routers. But if we don't use the always, we have to make sure on the device we use the show IP router, we can see the default route information in our routing table, and then we can deliver the default route successfully. And if we use the default information originate always this command. So for the network, actually, sometimes we're cause some problems. So be careful use this comment. Okay, maybe sometimes the routers belongs to the OSPF domain can't access the external network because in our device we don't have the default routing entry. Okay, so this is the part about the default route.